welcome. This is Chapter 2, Section 8, Solving Absolute Value Equations and Inequalities. So the objectives for today, you will be able to solve compound inequalities. You will also write and solve absolute value equations and inequalities. All right, you have 3 vocabulary words that you're going to learn for this lesson. The first one is disjunction. The second one is conjunction. And then the last one is absolute value. You probably are familiar with those words, but let's get going with them. All right, so if you have a compound statement, it's a statement that is made up of more than one equation or inequality. And when you have 2, you may have a disjunction. That means that the compound statement that uses the word or. All right, so a disjunction is going to use the word or. Let's look at an example of that. All right, so here you see a graph. And you see that a disjunction, you see that x is less than or equal to -3, or x could be greater than 2. So this is called a disjunction. And in set builder notation, it's written like this: x such that x is less than or equal to -3, or, and when we see this U looking thing, that means or, x is greater than 2. All right, so you could also say a disjunction is true if and only if at least one of its parts is true. So they don't have to both be true. You could have x equals -6 and it's true. You could say x equals 8 and it's still true. So you don't have to have both parts true, just one part, and that's because it's or. All right, but we also have a conjunction, and a conjunction is a compound statement that uses the word and. So let's look at a sample. So in this example here, we see a conjunction. We have x is greater than -3. So it's everything greater than -3. And x is also less than 2. All right, so written in set builder notation, we see x such that x is greater than or equal to -3, and then we have this upside down U, and I always kind of think of that like an A, so it reminds me, and x is less than 2. So a conjunction is going to have an and statement. Now, the conjunction is true if and only if all of its parts are true. Conjunctions can be written as a single statement as shown. So here's our 2 separate statements, but it could also be written as a single statement. -3 less than or equal to x less than 2. And so when we look at this, we see -3 is x is actually greater than -3 and it's less than 2. All right, so one way to help me remember this, and maybe it will help you too, dis means apart. So disjunctions have 2 separate pieces, and I think of the word dislocated. So I see this shoulder here on my little man has a dislocated shoulder and they're separated. When I think of the word con, I think of that as being together. So conjunctions represent one piece. So maybe this little visual here will help you remember that. All right, so let's get started solving some problems. We're going to start out with this one. 6y is less than -24, or y plus 5 is greater than 3. So the very first thing we want to do for this is just solve for y. So let's go ahead and solve for y. This is an easy one. We just want to divide both sides by 6. So let's divide both sides by 6. So that leaves us with y is less than -4. Or let's subtract 5 on both of these. So that tells us that y is less than or equal to -2. All right, so next it says for us to graph this solution set. So we're going to say, draw a graph here. And let's come over here, -4, 5, -6. And it says that y is anything less than -4. So we're going to have an open circle, and it's less than, so we're going to shade in the left. All right. Now it also says it could be, or it could be y is greater than -2. So let's just put a -2, and it could be equal. Okay, so I'm going to solid that, and it's going to be anything greater. So there it is. All right, so your solution set is going to be all the points that satisfy y such that y is less than -4 or y is greater than equal to -2. I'm going to put all that in these little brackets. You could also write this information in interval notation, and the way that would be would be -infinity, and notice I used the rounded brackets, to -4. -4 is not included, so again we'll use the rounded brackets. And then we're going to say this little U shape, which means or, so it's going to be this interval or this interval, and the 2 is included in this one, and it goes all the way to positive infinity. And there's no ending on infinity, so we'll put a rounded interval bracket. Okay, there we go. Let's try another problem. All right, this one, again, the very first thing we want to do is solve both inequalities for C. So the first thing I'm going to do, I'm going to go ahead and write down the problem. And the way we solve, we would multiply both sides by 2. So let's multiply 2. So the 2's cross out, so we have C is greater than or equal to -4. And then over here, 2c plus 1 is less than 1. Let's subtract 1 from both sides. That leaves us with 2c is less than 0, so c is less than 0. All right, so the solution set is the set of points that satisfy both of these. All right, both of these, and that's an and in here. All right, let's draw our graph of this. Pretty simple graph again. We're going to start with our 0 over here, and it says C is less than 0. It doesn't include it, so I'm just going to have that like that. Okay, and then we have -1, -2, -3, -4. We'll go ahead and put -5 in there. It says C is greater than or equal to -4, so we're going to color that in, and that is greater than, so that's going this direction. This one is going this direction, so everything in between here is a solution set to our problem. All right, and to write that in interval notation, we're going to write this bracket, the square bracket, and because -4 is included in it, and it goes to 0, which is not included, so we use the rounded. All right, let's try another sample. Here we have 2, and we're using the or again. So the very first thing, again, almost always, not almost always, but always, we want to solve both inequalities, in this case for x. So I'm looking at this, and I see that -5 or a -5 is connected to my x. So let's add 5 to both sides of this equation. And that's going to give us x is less than 3. Or this time we have to divide both sides by -2 to solve for x. Now remember, when we divide by -2, we have to change our sign. So instead of less than equal to, we're now greater than or equal to. So x is greater than or equal to -10 divided by -2 is a +5. So here we have, and so our solution set would say is all the set of all the points that satisfy x, I'm going to just do it like this, such that x is less than 3 or x is greater than equal to 5. And we'll put our little brackets around it, and there you go. All right, and it says to graph this solution. So when we graph it, we will start over here at 3, 2, 1, 0, and it says that x is less than 3. So it doesn't say equal to, so we're going to have that circled out, and then it's everything less than 3. All right, and it says that x is greater than or equal to 5. So let's put that in. Here's our 5. It is equal to or greater than, so I color that in, and there's my arrow. And if we wanted to write that in interval notation, we would say negative infinity. We're going to use negative infinity to 3, and that is not included, so we have a rounded. And then we're going to use this symbol, the U, which reminds us that it's OR. And then 5 is included, so we use the square bracket, 5, and that goes all the way to positive infinity. And there's no end with positive, so we have the rounded bracket. All right, let's move on to the next problem. This one's a little bit interesting, so I pulled this out. Let's see what happens when we do this one. Again, the first thing we want to do is solve for both inequalities for x. So again, let's add 5 to both sides. And so we have x is less than 17. And here, let's divide both sides by 6. So we have x is less than or equal to 2. All right, so our let's talk about what this looks like. Let's graph this x is less than 17. All right, so we have 17 over here, and it's not included, but everything less than is included. All right, so here we have x is less than 17. Well, our other one, or, says that x is less than 2. So 2 is down here, and it's included, and it's everything less than. So really, we only have to say one thing on this, and we say that because every point that satisfies x is less than 2 also satisfies that x is less than 17. Sorry, everything that satisfies x is less than 17 also satisfies x is less than 2. We just have to say for our set is the set of x such that x is less than 17. And that's what it would look like written like that. And for our interval notation, we see that it's all the way negative infinity, and it goes to 17. It's not included with 17, so our bracket is rounded. All right, let's talk about this for a minute. Okay, the absolute value. All right, absolute value, you may remember, and sometimes this gets kind of confusing here, so I want you to really think about what absolute value is. It's the distance, it's written like this, and it's the distance from x to 0 on the number line, okay? Because absolute value represents distance, and we don't have negative distances. Without regard to direction, the absolute value of any real number is non-negative. So let's just kind of make a little picture of this. 0, the absolute value of, let's say, 3, or our example here says 5, so we'll use that. The distance from 0 to 5 is also the same distance from 0 to negative 5. So when we're talking about absolute value, you need to keep in mind distance, all right? So the absolute value of 5 is equal to 5, but it's also the absolute value of negative 5 is also equal to 5. All right. Absolute value equations and inequalities can be written by compound statements. So consider the equation absolute value equals 3. So think about that. What could this x be? Well, the x could be a negative 3, because that's negative 3 points from 0, or it could be a positive 3. So let's look at a few words. Okay, there are 2 points that are 3 units from 0. The solution then is a disjunction, right? So it's either going to be x is either going to equal negative 3 or, which makes it a disjunction, x is equal to positive 3. All right, so when we see absolute values, you're always going to be thinking about disjunctions because there's going to be 2 of them. All right, but they're also going to be conjunctions too. So here's an example of a conjunction actually. So this one says it's an inequality. It says the solutions of x, absolute value of x is less than 3. So don't get tricked up by this because this is really confusing. And I would like you to put the video on pause for a minute and write these words down and draw this sample because this is really can get really confusing, and I want you to have this in your notes. Okay, so now that you've written your note down and you've turned your computer back, your video back going, let's get going. So let's talk about what this means. The solutions of absolute value of x less than 3 are the points that are less than 3 units from 0. Okay, so here's 3 units from 0 here and 3 units from 0 here. So actually we have x is going to be, all of this is less than 3 units from 0. And all of this is less than 3 units from 0. So when we have a less than sign up here, we're going to actually be doing a conjunction. So we're going to be having an and statement. So we'll have 2 equations, but they're going to be headed towards each other. All right. And equally confusing at times for students, the solution of absolute value of x is greater than 3 are the points that are more than 3 units from 0. So when it's greater than, it's got to be more than 3 units greater than from 0. So here's our 0. Here's 3 units away from 0. Remember, absolute value does not mean more negative or something. It just means how far away the distance, and in this case it says it has to be more than 3 units from 0. So it's pretty easy to see that on the right side. Here's 3 and all the points further away get bigger. Okay, but notice that here's our distance from 3 on the left side. All of our points on this side are actually getting smaller because they are further away from 0, which is what our question says, is I want all the points that are greater than 3 units away from 0. So actually this equation has to get changed to x is less than -3. All right, that gets kind of confusing. I'd like you to put your video on pause and write this out in your notes. I am going to ask to see this in class. So write this note out so you have it, and I want to see this when you get to class that you wrote this into your notes. Okay, let's keep moving. Here's a helpful hint. Think about this. If you have greater inequalities, so that means involving greater than or greater than and equal, symbols are disjunction. Okay, so if you have a greater than, you're going to see that or, great or, and so you will be doing disjunction. So they're going to be greater from a distance. So if we have a distance of, say, 3 and it says greater than, it's got to be a distance greater than 3 and a distance greater than, say, -3 going this way. All right, so when we see less than, let's think about the and in less than. It's not quite like that, but it's a way to think about it. When you're using the less than symbols, we can think, okay, 0, 3, -3, it's less than that distance. So this is less than the distance of -3. This is less than the distance of +3. So this is an and statement. It's going to be filled up. It's going to be one line connected. Okay, these are going to be or 2 lines disconnected and 1 line connected. Conjunctions connected, disjunctions disconnected. All right, here it is written a different way for you. If absolute value of x equals a, so that means x is going to either equal -a or x is going to equal a. Next one over here, when absolute value is less than and a, we're going to use an and sign. So x is going to actually be greater than negative a, and x is going to be less than positive a. Again, if you think about it on our map here, this is actually numbers here. Let's say this is negative 3 and this is positive 3. Again, x is going to be greater than our negative 3 and less than our positive 3. Okay, next we have when x is greater than a, greater or, again, that tells us that we're going to have two disjunctions. We're going to have, let's use 3 again, negative 3 and positive 3. X is going to have to be greater. Doesn't mean that negative 4 is greater than negative 3. It means it's a greater distance away. Okay, so in this case, think about it as distance. Don't think about it as the number being greater. It's the distance away from 0 that's greater. And same over here. It's the distance that's greater than 3 that we're concerned about, not the actual number, although on that side the number is actually bigger. But we're thinking about distance, not the actual number, just the distance away from 0. That's the key thing. It's the distance away from 0. All right, so here we go. Let's do a sample of these. We have solved the equation, and this can be read, what is the distance? This distance is going to be equal, this is an absolute, so it's going to be equal to 10. So we have to write two different equations. We're going to say negative 3 plus k, that is going to be 10, equal 10. That would be the 10 units away from 0 on the right. But negative 3 plus k equals negative 10. That would be 10 units on the left of 0, still the same distance away from 0. So let's just go ahead and solve for k. So add 3 to both sides. So we end up with k is equal to 13. And we said that let's add 3 to this side, add 3 to this side. So k is equal to 7. Oops, said negative 7. All right, so that's all you have to do to solve that equation. That's not too bad with our inequality, or not our inequality, with our absolute value. All right, let's do another absolute value problem. Here, once again, we want to isolate our absolute value by itself, so let's add 6 to both sides. And now we have absolute value x divided by 4 is equal to 4. All right, so now we know that the distance is going to be 4 away from 0. So we're going to say x divided by 4 is going to equal 4 on the right side, but x divided by 4 is also going to equal negative 4 because that's 4 units on the left side. And remember, it's distance, distance, distance. So let's go ahead and multiply both sides by 4. So we have x is equal to 16. We multiply both sides over here by 4, or x is equal to negative 16. So that's a pretty simple thing. All right, let's do just a few extra notes. You can solve an absolute value inequality using the same methods that are used to solve an absolute value equation. So you want to isolate the absolute value expression if necessary, then rewrite the absolute value expression as a compound inequality, and then solve each part of the compound inequality for x. So this is your hardest step right here. Rewriting the absolute value expression as a compound inequality. So you're going to have to really think about each of these problems. So let's do a practice one here. Solve the inequality, then graph the solution. Okay, so the very first thing we want to do is rewrite the absolute value as a disjunction. And why is it disjunction? Because this symbol says greater. So we're going to use the word or. So let me just let's just write this out so we can kind of get a visual for what this is going to look like. It says, and remember, this absolute value is talking about distance, not exactly the size of our number, but the distance away from 10. Okay, so it says it wants to be greater than the distance of 10. So we can easily see this one. Here's 10, and it's greater than or equal to. It's going to be greater, so it's that way. But the absolute value of that is also going to be, could be negative 10, because the distance away, and it needs to be greater than our absolute value. So the distance needs to be greater than negative 10. Don't think about the numbers, because negative 11 obviously is smaller than negative 10. But the distance away from negative 10, from 0, this distance is greater, all right? So you have to get out of your mind negative numbers over here and just think about distance. All right, so now that we have that set up, let's go ahead and write our problem out. We're going to have two equations. The first one, the easy one, where it's greater than or less than 10, negative 4q plus 2 is greater than or equal to 10. All right, and but we're going to actually say or, absolute value of 4q plus 2, that has to be everything less than negative 10. So we're going to make that say less than or equal to negative 10. All right, so now we can just now we can solve our equation. Let's drop the absolute value sign, negative 4q plus 2, and let's subtract 2 from both sides. That would give us negative 4q is greater than or equal to 8. Now, here's the tricky thing. Negative 4, we got to divide both sides by negative 4, so we have to change our sign. Q is now going to be less than or equal to negative 2. And over here we have 4q plus 2 equal to negative 10. Let's subtract 2 from both sides. Now we have 4q, and left all my negatives off of my 4q. 4q less than or equal to negative 12. We have to divide both sides by negative 4, so that's going to change our inequality sign. So we're going to say q is now greater than or equal to positive 3. Okay, so the next thing we want to do is graph this solution. So it's going to be all the points in this set are going to be that would satisfy our statement up here. Let's go to negative 2, and it says q is going to be less than or equal to negative 2. So we can shade that in, and it's going to be everything in this direction. Remember, these numbers are actually smaller, but we're not talking about what the numbers actually are. We're talking about the distance from 0 is greater as we go out this way. And then the distance from 3 is greater than, so it's going to go this way. All right, so keep in mind we're talking about distance, not the actual negative, but the distance from 0. I hope that helps. I want to just keep on emphasizing that. All right, here's another one that I want to do for you. So first of all, let's isolate the absolute so that the absolute value is by itself, and we're going to do that by adding 3 to both sides. So we end up with an absolute value of 0.5 times r is greater than 0. All right, so when we see the word greater, we're going to use an or statement. All right, and this one is going to be the absolute value of 0.5 times r is also has to be less than or equal to 0. All right, so when we work this out to solve it, we divide by 0.5 on both sides. Divide by 0.5 on both sides. We end up with r is greater than or equal to 0, and r is less than or equal to 0. So when we plot that on our graph, we have 0, and this one says r is greater than, so it's all this direction. And this r says r is less than 0, so it's all this direction. So we end up having the solution is all real numbers. All right, and so in interval notation, it would be negative infinity to positive infinity. All real numbers. And you could do the R sign. All right, so let's solve the compound inequality, then graph this one. Here we go. The very first thing we want to do is multiply both sides by 3 so we can isolate our absolute value. So if we multiply both sides by 3, these cross out, so we end up with absolute value, that's my brain thinking, absolute value 2x plus 7 is less than and 1. All right, so that tells us we're going to have an and statement. So it's going to be less than the distance away. So let's say 0, let's put our 1 over here and a negative 1 over here. It's going to be less than this distance. It's not going to be greater than this distance. So don't be thinking about negative numbers, just be thinking about the distance. So this one's going to be less than our negative there. And from this side, it's going to be less than our 1. So it's going to be a conjunction. It's connect these. So let's go ahead and write our equations out the way they should be. Actually, this 1 times 3, let's get that corrected. All right, so let's write them out. We're going to have 2x plus 7 is less than or equal to 3. So that's going to satisfy this condition. And then we're going to have 2x plus 7 has got to be greater than or equal to negative 3, because it's negative on this side. All right, so let's go ahead and solve these two for x. So let's subtract 7 from both sides, and that leaves me with 2x is less than or equal to negative 4. Divide both sides by 2, and we have x is less than or equal to negative 2. And then over here, again, we're going to subtract 7, so we have 2x is greater than or equal to negative 10. Divide both sides by 2, leaves us with x is less than or equal to negative 5. All right, and then finally, we just need to graph this. And so it should end up looking like our conjunction graph up there. So it says x is everything less than or equal to negative 2. So let's draw our negative 2. And actually, I'm going to do this one first. X is everything greater than negative 5. So let's do negative 5 over here. It's going to be greater than this going to the right, and then we have our negative 2 over here, and that's equal, and so it's going to be all of this in this shaded area in there. So our solution set is going to say x such that x is less than, let's see, I'm going to rewrite this a little bit different for us. Let's try this other notation. Let's start with the smallest number, which is negative 5, is going to be less than or equal to x. Okay, just like that. And then we're going to take this one over here, which is less than or equal to negative 2. And there's a new way of writing that one. All right, and let's see. Let's do one more, and then we're going to be finished. So here's our last one. Again, we want to isolate our absolute value. So let's multiply both sides by a negative 2. Negative 2. So this crosses out, and this becomes negative 6. And notice when I multiply by negative 2, I have to change my sign. So I'm going to change that. And so that leaves me with p minus 2, the absolute value, is less than or equal to negative 6. So less than is and means it's connected. So right now this is a negative 6, and that just means what's the distance away from 0, all right? So it's going to end up being 6 away from 0. and this is and so it says it's going to be less than the distance to 6. So that means it's all this is less than the distance from 6. So we're going to be talking about this and less than the distance of this 6. All right, so let's go ahead and solve our equation now. Or let's write our second equation. So we already have p minus 2 is going to be less than or equal to negative 6. So that distance, not the number. And then the other one is going to be p minus 2 is going to be less than, greater than the distance. Oh, sorry, I'm getting confused on myself here. It's got to be less than, oh, okay, I know what happened. And here we're going to have to say that p minus 6 is going to be greater than or equal to positive 6. But because we have to do our signs, but when we just look at this, we can kind of guess that this isn't going to work out, but let's just do it anyway. P minus 2 is less than or equal to negative 6. Add 2 to both sides. We have P is less than or equal to negative 4. When we do it over here, add 2 to both sides. We have P is greater than or equal to 8. And actually, because no real number satisfies both, P is less than negative 4 and P is greater than 8, there is no solution. So the solution set is the empty set. So I'm just going to graphically show that to you for a minute here. We have 0, negative 4, and P is less than negative 4, which right away tells us that something's not right because this is an and so we're not headed towards the 0. And this one, P is greater than 8. That is not going to work for us either because it's going in the wrong direction too. So this is an and statement, but we ended up with an or equation. Let's go ahead and put this because it was less than. So we ended up with an or situation, and that doesn't work for us. So there we go. All right, and that's the end of your video. My Bible message for you today is Jeremiah 29:11. For I know the plans I have for you, declares the Lord. Plans to prosper you and not to harm you. Plans to give you hope and a future. And my prayer is for your wonderful hope and a future. I will see you next time.